Alright, so here's a supplemental video for dealing with the notebook itself and how to navigate the code. Now, I took this first code block straight out of the notebook. And here's a code block, and I also grabbed this text block. And I've taken it and I've broken it down into what happens in each statement, but I took it, just copied and pasted in a blank notebook. Now, I've added some comments in. And if we look at this, like I said in the other video, ignore the driver code. Because this driver code does the same thing every time. We're not looking at the driver code, we're looking at this function or this algorithm, the work that we're doing here. That's the important part. Because if it's 5 long or it's 500 trillion long, that's a big deal. If I told you I need you to wash my car for me, and it's a little smart car, won't take long. If my car is a tour bus, it might take you a while. You might need special tools to get it done. Now, let's look at this algorithm, function, pseudocode. We do the same thing to any of these. But predominantly, we're going to deal with the pseudocode version or some version of code and break it down and analyze each statement that's in it. Now, this only happens, the declaration, that only happens one time. We're not going to focus on that. When we get to this loop, we deal with n. Now, n is traditionally the length of an array, or the size, how big this data is. I don't mean how big a number is. It's how many entries in a database, how many items in a dictionary, how many items in an array, how many items in a list. Now, when we look back at data types, the dictionary could be a list, a linked list, but it's still, in essence, a list, linking to other lists. Now, for this, we've got a list that has 5 items in it. It's got a length of 5, 0 to 4. This len function is being passed an argument, which is that list, to identify how long is this thing. We're going to go from 1 to the length. Okay, from 1 to the length. That's how many times we're going to go through this. I could have gone from 0 to that minus 1. Same thing. Doesn't matter. Okay. The only thing that's different is where we start. Now, we come down to this. This statement here takes n time, n being the length of the array. That's how many times we go through this structure. So if the length of the array is 5, we go through it 5 times. If the length of the array or the list is 500 trillion, we're going through this thing 500 trillion times. So it takes n time. This takes constant time. You only do it once in each iteration, but it only happens once in there. So I'm looking at, in here, this statement, how many times is this statement? I don't look at it from the standpoint of, oh, so this thing's, you could do the sum of all, and it still ends up being n is the predominant number. So just look at it, it only happens once in each iteration. This only happens once in each iteration. How many times does this happen in each iteration? Well, this happens n times again, because we could go all the way up to the key being at the end, or maybe one away from the end of that list. Now, in the whole scheme of things, when we're talking about a length of 500 trillion, does one way or the other make that big a difference when we're talking about how much time it takes to get through it? If I said, look, I got 500 trillion cars I need you to wash for me, would it matter if I said 500 trillion and one? Would that be a big deal? I don't think it would. I don't think that'd be a deal breaker. You know what? I'll wash 500 trillion, but I'm not going to wash one more. That one more just becomes insignificant compared to the 500 trillion part. The amount of time it takes to do the work of one more is not significant when we look at how long it takes to do 500 trillion. So we leave that one away. We ignore that one. So this nested loop takes n time to do it, and essentially it's really n minus 1, but we drop off that one, we ignore it. This only happens once, and they're constant, constant, and constant. So, with that said, I've got an n, and within that n is nested another loop, which takes n, so that ends up being n times n. N times n, n squared. So you just double click, it's an n squared. If there was only the one loop and not a nested loop inside, what's the worst of everything we see here? Constant, constant, n. O of n. That's worst case scenario. Doesn't mean necessarily that's what's going to happen. Somebody could call that function and pass it a list of 2. Man, I got off lucky on that one. It was an easy one compared to 500 trillion. Yeah, but we don't look at what's best case scenario when we're talking about this. What's worst case scenario? So let's come down and look at, I pulled this from Geeks for Geeks. Now, this is binary search, and there's a couple of ways we could do binary search coding wise, and this one is the best example for what we're going to go play with now. Now, this is a recursive binary search, and the recursive binary search, we go look at what's taken place, and let's break it down step by step by step. So if we look at this, one, and traditionally we just ignore that call because it doesn't even happen in the function, but it does happen. And if we come in here, if r is greater than or equal to 1, how many times do we do that? The same. It's not in a loop, so we only do that one time. We check to see if the number on the right, which is the end of the list, number on the left is the beginning of the list. So 0, len minus 1, what we're looking for it in. That's our numbers. So that's the number we're looking for is 10, and we're looking for it in here. So we did this once. And once we do it, we don't have to do it again. This is not a loop. This is recursive, meaning it calls itself. So let's come in here and say, this line right here, how many times does this happen? So we're in this loop. Now we're not in a loop. We're in this conditional. So assuming this was greater than or equal to 1. So there's some length more than 1. The list is longer than 1. Then we get down in here. How many times do we do this? Once. What are we doing? Well, we're adding 1 to that number at the far right side. Minus 1, so no, it's L plus, sorry. This is hard to see whether we're talking about ones or L's. So L plus R minus L. Divided by 2, drop the remainder. That's our new midpoint. So midpoint, let me talk about midpoint. All right. So L was 0. R minus 1. So R was the index. So that's 4. Minus 1 is 3. Is it 4 minus 1? It is 4 minus 1. So 3. 1. Is that what we hit? No, we hit 0. 0 plus 4. So it's 4 divided by 2 is 2. So mid is now 2. So that's our halfway point. Now halfway point between 1 excuse me, 0 and 4, well, it's 2.5, but they say let's drop it down by 1 and we'll just call it 2. So our midpoint is 2, and we say, look, is the midpoint what we're looking for? If it is, we found it. Now, how many times does this happen? Once. Worst case, how many times does that happen? Once. It may not happen, but it could happen once. This does happen once. This could happen once. Now, we didn't find it. And we said, well, is the mid greater than X? How many times are we going to do that? 1. How many times do we do this? 1. 1. 1. And 1. So this seems kind of hokey, doesn't it? I only do everything once. Once. But what I'm doing here is I'm calling one of these 3 things is going to happen. Either I found it, or I say, you know what? It's either in the bottom or the top half. So I cut this in half, right? So what I'm looking for is either in the low half or the high half. All right. How many times am I having to do this now? So if I had 5, if n was 5, I'm not doing it 5 times, and I'm not doing it half of 5 times. I've got some other calculation taking place in there. And essentially, the number of calculations that are taking place is this right here. So I go through the first time. I did one comparison. Do it the second time. I've got two comparisons now. Do it a third time. It's 3 times 3 comparisons. How many times do I go through this? Well, I essentially go through it log n times log n comparisons. So with this, we go through, we do the math, and we break it all down. And how we break it down is 1 times 1, 1, 2 times 2, 4, but 3 times 4, and I keep going, and what I end up with at the end, all the way down here at the end, is log of n times, and this right here, the funny calculation is where we deal with the logs. So we've got 2 to the log n minus 1 power. And I'm not going to make you go do all the math associated with this. This is something we can go look up and find out what is the time complexity for this algorithm. But by cutting it in half, cutting it in half, we're doing log of n. So when I come down here at the bottom, and I'll copy that cell, I'll paste another one here. So our time complexity on this is log n, and it's not hat n, it's log of n. So it's smaller than n. It's significantly smaller than n. So that's what this one is. You could go through this and you say, you know what? I went through each line in there. And this is one of the more difficult ones because a lot of you aren't familiar with how a log works, how logarithms work, or it may have been a while since you've done that. But if everything was constant, then it's constant. If I have to go through item by item in the list, front to back, that's n, because I've got to go through all the items in there, every index. And depending on how long that is, that could take a really, really long time. So the code that you've got, I'll go back over to this notebook, the code you've got, go through and look at each line. So here's a line. How many times do you do that? I'll give you this line. This one is constant. That's what it is. Now you come down. How many times do you do this? Now, I talked about what's taking place here, tail end of the other video. You look at each statement And in each statement, how long does it take to do it? Is it constant? Is it n? Is it what is it? Once you've come up with whatever that is, double click here. O. And then fill in the parentheses. What is it? Is it 1? Is it n? Log of n? N squared? N factorial? What is it? All right. That's how you go through and do each of these. How many times? Here's the length of the array, or the array. We're going to deal with the length of the array. Position on the left, position on the right, what we're looking for. Now, this is similar to what I just went over. This is similar to what I just went over. It's a simple search. Could be called something else. Go through these, item by item. How many times do we do this line? How many times do we do this? How many times do we do this? How many times do we do that? What's the worst that we see? Boom, that's what goes in here. It's the worst that we see? Boom, and it goes in there. Things like insert, go look and see in the link that I gave you in the previous video how long it takes to do insert. We may call it once, but there's work happening behind the scenes. Some things are trivial. An assignment, that's trivial. This is a conversion, or you're finding the index of an element. That's got some value to it. This has got some value to it. So how long is it taking to do these tasks? And you'll just go through each one. How long does it take? Okay. All right, if you got questions, reach out to me, and I'll talk to you soon.